All right, 2018 BC5 has polar curves on it. We have two polar curves. First of all, anything that just says r equals a number, because r is the distance from the origin, that is a circle centered at 0. So this outer curve is r equals 4. Okay, and then this cardioid shape, which is this piece in here, that's got to be the one that's funny looking, with the r equals 3 plus 2 cosine theta. Okay, it's called a cardioid. Okay, and so for part A, we have the shaded region inside r equals 4, but outside the cardioid. So what we're going to do, and they're really nice, they tell us the points of intersection. So points of intersection are actually rays in polar curves. So this is theta equals pi over 3 over here, and theta equals 5 pi over 3 is over here. Okay, so what I'm going to do is I'm going to take the area of the circle from here out and around, and then I'm going to subtract off the area inside the cardioid. So the way that we find area in polar curves is we do 1/2 the integral from theta equals a to theta equals b of r squared d theta. So that green stuff that I just noted is going to be 1/2 the integral from, and they're so lovely giving us these bounds. Normally we would have to solve for them. I'm going from pi over 3 to 5 pi over 3. Okay, and I'm doing r, which is 4, so 4 squared d theta. Okay, do you guys see how it says just to write the integral expression? It does not ask us to solve for the integral. Okay, and then what I want to do is I want to subtract off this stuff in here and get rid of that. So I'm going to do minus 1/2 the integral from pi over 3 to 5 pi over 3 again of r, which is 3 plus 2 cosine theta, quantity squared d theta. Okay, so I'm just doing 1/2 the integral of r squared d theta. And that is part A. Part B is very annoying. Anytime you guys are asked for slope for part B, slope is dy dx, or y prime over x prime. The problem is that there's no y's or x's in polar curves. So we need to know two relationships. We need to know that y equals r sine theta, and we need to know that x equals r cosine theta. Okay, so my y is going to be r, which is 3 plus 2 cosine theta, times sine theta. And my x is going to be r, which is still 3 plus 2 cosine theta, times cosine theta. And then for my slope, I'm going to be doing y prime over x prime. And when I take the derivatives of these things, I'm going to have to use product rule. So I'm going to do first, so I'm starting with y, I'm going to take the derivative of y. So I'm going to do first 3 plus 2 cosine theta times the derivative of the second, derivative of sine theta is cosine theta, plus the second times the derivative of the first, so plus sine theta times the derivative of 3 plus 2 cosine theta would be negative 2 sine theta, over, I'm now going to take the derivative of this x using product rule. So I'm going to do first 3 plus 2 cosine theta times the derivative of the second, the derivative of cosine theta is negative sine theta, plus the second cosine theta times the derivative of the first, the derivative of 3 plus 2 cosine theta is still negative 2 sine theta. Okay, and then it wants me to do this at theta equals pi over 2. Okay, so I'm going to have 3 plus cosine, or 2 cosine pi over 2, cosine pi over 2 is 0, times cosine of pi over 2 is 0, plus sine of pi over 2 is 1, times negative 2 times sine of pi over 2, sine of pi over 2 is 1, so negative 2, over, I'm going to have 3 plus 0 again, because that's the same expression from the numerator, times negative sine theta. Sine of pi over 2 is 1, so it's going to be -1, plus cosine theta, which is a 0, times -2 sine theta is still -2. Okay, and guess what? You can leave your answer like this. You can sure as heck simplify it if you want to. This is all 0, so I get a -2 on top. And then this is a 0, and so I have a -3 on bottom. And I could leave it like that. I could write it as 2/3, but I'm also more than welcome to just leave it like this, and I get my answer, my points for my answer. Okay. These relationships come from the fact that if you guys go back to when you first were defining sine we said was y over r, and then I multiply both sides by r and I get y equals r sine theta, and cosine theta is x over r. This is like back to the unit circle where I had some point here, xy, and I had the radius r on the unit circle, and if I did sine of theta, it would be opposite over hypotenuse. So it would be y value over r, and that's where that comes from. Okay. And same thing, cosine theta would have been x over r, and so x equals r cosine theta. So that's where those things come from. For part C is one of these funny problems where it starts to talk about rates of change where suddenly time is in the mix, right? Because it says that the particle moves in such a way that the distance between the particle and the origin increases at a constant rate of 3 units per second. Okay, so there's r's and there's thetas here, and suddenly there's seconds. So that means that we're taking our derivative implicitly with respect to time. So first of all, I need you to understand that r is the distance between, what's the distance from your point, from the origin. So it's the distance from the origin. So when it says the distance between the particle and the origin is increasing, that's a dr dt. And it's dt because it's in 3 units per second. Okay, that's why it's dt. And I want the rate at which angle theta is changing with respect to time. So d theta dt is my unknown here. So what I'm going to do is I'm going to take the derivative of this equation implicitly with respect to time. So I have r equals 3 plus 2 cosine theta. The derivative of r is 1, but hey, I just took the derivative with respect to time, equals the derivative of 3 plus 2 cosine theta is -2 sine theta, but hey, I just took this derivative with respect to time. dr dt they gave us was 3. I'm going to have -2 times sine of pi over 3, because they're telling me at the instant when theta equals pi over 3, and I have a d theta dt here. And then I'm just going to divide out. So I'm going to have d theta dt equals 3 divided by -2 times sine of pi over 3. It's the free response section, so I don't have to simplify my answers. Okay, it says to indicate units of measure. Theta is an angle. We measure our angle in radians. So this is going to be in radians per second, just like r was in units per second. This is going to be in radians per second because it's a rate of change of an angle. I don't know if that was helpful or not. Let me know.